Welcome to Science Encyclopedia College. Now, we have the subject we're going to be considering, which is physics, a topic in under classical mechanics, which is referred to as kinematics, that is motion analysis. Now, what is kinematics? Kinematics is a branch of physics that deals with the study of motion without considering the forces that are responsible for this motion. Now, we have what kinematics simply describes. It simply describes four parameters. The first one is displacement, followed by acceleration, velocity, and then time. Now, under this kinematics, we're also going to be looking at the types of motion. Now, before we go into the types of motion, please don't forget to like, to share, and to subscribe to my channel for more videos. Now, there are basically four types of motion. The first one is rectilinear motion, that's motion on a straight line. Then secondly, we have curvilinear motion, that's motion along a curved path. Motion along a curved path. Then the next one we have is rotational motion, that is motion that takes place along a fixed axis, motion around a fixed axis. Then the last one we have is projectile motion. This is a two-dimensional motion that occurs under gravity. Now, under this kinematics, we're also going to be looking at basic important equation in kinematics, that's basic kinematic equation or important kinematic equations. Now, the first one is V equals to U plus AT. Now, 2 is S equals to UT plus 1 over 2AT squared. Then the third one is V squared equals to U squared plus 2AS. Then the last one is S equals to U plus V over 2 close bracket, then multiplied by T. Now, these are the equations that are considered in kinematics when you are discussing, considering constant acceleration. So these equations are applied under constant acceleration. Now, the next thing we must consider when we are done with the important equations in kinematics is also motion, projectile motion. Now, there is projectile motion, that is motion that is free fall. There are free fall and projectile motion. Now, in this projectile motion, we are actually saying that it is a vertical motion that occurs in a vertical direction. Now, in this motion, G is always given, or sometimes given as 9.8 meters per second squared. Sometimes you have it as 10 meters per second squared. So mostly we go with 9.8 meters per second squared because of other factors. Now, in this, when we are considering free fall and projectile motion, we have equations that are used to calculate this. The first one is H, which is for height, the vertical distance, which is equal to 1 over 2 gt squared. Then we also have the next one is V. We have V is given as gt. Then we also have V squared, which is given as 2gh. Now, this is what we consider, or we make use of. These are the equations that we make use of when we are discussing free fall and projectile motion. And then, of course, we have circular motion. When you are discussing kinematics, you must consider circular motion. So sometimes you have a motion that is circular. So we have a uniform circular motion, you can call it like that. Now, there are equations we use for that circular motion, which is the first one is centripetal acceleration, which is given as V squared over R. Then we also have the next thing is the angular velocity represented using the sign omega, which is equal to V over R. And the last one we have is we have the period using T. Period T is equal to 2 pi R over V. Now, the V here, don't forget, is not velocity. It's not the same thing as what is here. The V here is not velocity, but it is referred to as speed. The R here is reduced. So V is speed, while R is radius. The radius are considering along the circular path. Now, lastly, we look at relative motion. When you're talking about kinetics, there are relative motion. Relative motion, which is referred to as relative velocity. Now, relative velocity is calculated using this AB equals VAB. VAB equals to VA minus VB. That is the velocity of the object minus the velocity of the observer. So, you can consider two objects moving in the opposite direction. So you can have velocity of the first object the first object, which is VA, minus velocity of the second object. So this is how you calculate relative velocity when you are considering kinematics. Don't forget, kinematics is a branch of physics that is very, very important in engineering. It is a tool for studying and understanding physics entirely and engineering as a course. Thank you for watching, and don't forget to like, to share, and I look forward to seeing you next time. Don't forget, this is just lesson 1. This is just lesson 1. We're going to be having lesson 1 to 20. Thank you.